Today, we will be discussing linked lists and we'll look at what a node is, the purpose of the head node, how to traverse a linked list, and how inserting and deleting nodes works. So to begin, what are nodes? Nodes are a data structure that stores two main pieces of information. The first piece being data, which can be in the form of a string, int, long, or etc. And the second being a pointer to the memory address of the next node in our list. Let's show this with an example. Here, our first node will be called the head. The head is the only node in our linked list that we have access to immediately. Remember this as we will revisit this idea in a bit. Let's first give the head a data value of 10 and point its next pointer to nothing, or what we like to call the null pointer. Next, we will add another node to this list. So firstly, we create a new list pointer, which we will assign a data value of 12, and point its next pointer to the null pointer, aka nothing. Now we can point our head node's next pointer to this new list node. And just like that, we have linked our nodes, hence the name linked list. Just to show it one more time, we will make another list node, give this one the value of 100, point its next pointer to null pointer, and point our previous node to this node. Notice how every new node points to the null pointer. This is to indicate the end of our list, which is why we call these nodes the tails. Now that we have a couple nodes in our list, how do we access these nodes? To accomplish this, we need to traverse our list starting from the only node we actually have access to, the head. We will now show traversal with an example. Let's say we want to find the first node with a value of 100. We would first initialize a list node pointer called current node. We will set current node equal to the head and check its data value. Head has a value of 10, so we set current node equal to head's next pointer. Current node now has a value of 12, which is still not right, so we set current node to its next pointer again. Now current node has a value of 100, so we can stop. This is essentially how linked list traversal works. We start from the head and work our way towards the desired node or until we reach the tail. Speaking of the tail, what if we wanted to insert a node not as the new tail? Let's show this by inserting a node in between these two. We will first create a new list node with value 55 and point its next pointer to this node. Then we will point this node's next pointer to our new node. And just like that, we have inserted a new node into our list. Deleting a node is just as easy. We first point this node to what our new node's next pointer was. Then we point our new node's next pointer to null pointer. And we can then delete this node separately from our linked list without breaking the connection or causing memory leaks. And that's pretty much it. As a quick recap, a node stores data and a next pointer. The head is the first node and the entry point to the list. To traverse a linked list, we start at the head and move one node at a time. To insert or delete, we update pointers so the list connects in the order we want.